My name is Andreas, and in the next few minutes, I like to show, like Jose mentioned, how to repair corrupt 3D models in TruTops Boost. So this is something which not only you facing every day by using Boost or creating models, sheet metal files. Also, we on our side get a lot of corrupt models and stuff. And I just want to give some insights how to handle these corrupt 3D files to get maybe in nice ways to a valid 3D model to then use the flat geometry to create then technology programs. And we at ScaleNC, so my team and me, we use, like many of you, TruTops Boost for creating these technology programs, and therefore I would want to show, as I mentioned, tips and tricks how to solve problems and repair models. And I prepared a few samples. The first one will be a solid file, and as you may see on the right side in the picture, this part will be shown afterwards in text zone design in Boost. It's made maybe from steel or sheet metal, but as you may already see, it's not possible to unfold because it has no bends or slits on the edges. And this is our first part. And I want to switch now to TruTops Boost. TruTops Boost is the programming suite. I think all of you will use it every day. And as I mentioned earlier, we also use it for creating the NC files for our customers. And just start with our corrupt solid file. I open text zone design. So this is the CAD tool of Boost. And as you can see, I have a 3D model, a solid, but this solid has no bends, no cuttings on the edges, and I am not able to create an unfolding that I can use for 2D cutting or programming the press brakes. And to start really slightly, I want to show how I can repair these kind of files in TruTops Boost by using functionality of this system. And in this case, it's really simple one. On top, I have this import functionality buttons, and one of these buttons is the conversion button. So convert means I want to, by clicking on it, I want to convert this solid file into a sheet metal part. And by clicking on it, you already can see that something happened to this model. These red lines came up, and Boost tries to convert these red edges in somehow, but at least it needs some helping from me to define maybe what should be bent and maybe where to cut the part. And to give this information to the part itself, I can use the modify section over here, and I have under this junction feature quite a lot of functionality, starting with bend and going on with overlaps and sharp edges and stuff like this. First of all, I want to create bendings on the bottom side of our model. Therefore, I will start the bend functionality, and by clicking on the red edges, Boost will modify my sharp edges and creates automatically some bends. Where I clicked on the red line, it automatically converts the line into a bend. And as you may see, the magenta colored corners are all having a radius, which means this is the bend I converted. And not only the bends are created, also the corner relief, which is maybe necessary in this case, is created automatic. This depends on some standard features of Boost. So you can define the shape how you want it as default, but this is also something which is then changeable in a fast and easy way afterwards. Coming back to our red lines, we have still 3 existing red edges, and on these remaining red lines, I want to create an overlap. So I change from bend to overlap. Clicking on the red edges will lead to that the red line disappears and my edge here is now a slit. And in our case, as you can see on the corner here, it has no overlap because I defined it like that. But at this stage, I'm already having a converted solid from, when we take a look at the start, from a non-valid sheet metal solid to a now maybe solid which is made for processing from sheet metal. And at this stage, I can now create a cutting geometry, so the 2D file, which then this can be used for laser cutting, punching, combined machining, and maybe also for programming of the press brake. As I mentioned earlier, maybe I want to adjust reliefs, overlaps on this part, because whatever, after bending, it needs to be welded, and the corners here, or the reliefs here in the corner, are too big. They need a different shape. So just one more additional thing. Everything which is colored here in Boost, so magenta or yellow, is adjustable and modifiable in a really easy way. So by using the select tool, I can, for example, select the relief. And as you can see, there is a shortcut as a suggestion, and Boost comes up with some suggestions how to change this relief in the corner. So for example, I can now say if I'm using a 2D laser machine, I can easily modify this corner into different geometry, so that at the end, after the bending process in this corner, only a small hole or nearly no hole is existing, so that I can weld it perfectly. And also the overlap is adjustable and modifiable by clicking on this magenta color. Boost also comes up with shortcut, and here I can maybe say I want, instead of no overlap, a partial overlap, for example. And then when we take a look on the corner, one side overlaps at the other side. And this is also something which is maybe adjustable, or maybe change the direction in a really fast and quick way. And it's also, I think it's, you can imagine that it is not only on this side and corner adjustable, it's on all existing reliefs and edges adjustable, so that when I modified my solid model at the end, I'm having that kind of 2D file, which is then cuttable and afterwards could be bent, welded, and whatever we have to do with these kind of model. So this was the first step. Started really slightly, take a look back on our first problem. It was the solid file. The model was not made for sheet metal. It was not possible to unfold it. And my solution with this conversion tool, I added some bends. I added and modified the overlap, and also the corner reliefs were created automatic, and everything I did, overlaps, corner reliefs, were adjustable afterwards. So every time such a corrupt solid model comes up in Boost during the import, I have this typical way to modify and repair it, that I can use it afterwards for every additional step I want to do. So this was the first problem. Now we're getting a little bit dive deeper into processing and repairing. And the second part I want to show is a part which is also not maybe suitable, made for sheet metal. It's also not possible to unfold it because it has missing bends. Maybe some faces in the bends are not drawn correctly. So also there quite a lot of problems why it is not possible to just import it and get a perfect 2D file out of it. Maybe just for explanation and why it happens stuff like this. So why are there corrupt parts? Just imagine when you, for example, do these things in an additional CAD system like SolidWorks, Inventor, just in these to speak about these big CAD systems. Every time parts are converted there from the native format into a step file or sub file or a common format, which is maybe shared by your customers. It could lead to that parts are not looking like they were made in the in this native CATD tool, and that could lead to that they are maybe corrupt after importing them into TruTops Boost. So also in this case, it is a step file, and as I mentioned earlier, the problem is I have this corrupt part with corrupt bands, missing faces in the bands, and I want to show how to solve this problem. And as you can maybe already see, and this is what we maybe learned from our first part, some bands are recognized automatic by Boost. So this is why they are magenta, and there is a letter and a number. That always means they are fully assigned. But also here we have maybe some bands which are not converted automatic during the import process of TruTops Boost. And therefore, it's necessary to do some additional steps. And I want to show two different ways how to solve such a problem to get a valid, solid model that I can then unfold like we did it with the first one. So the first step is I focus on the missing bands due to whatever, missing faces, not the correct radius. Sometimes the inside is sharp, the outside is round. These are all problems which can occur when you import these files. Getting started with this problem, I will select one band. And now by hitting my delete key on my keyboard, I can rebuild the file or the band into a sharp edge. Yeah. So I can do this to all the bands. So with the active select tool, I will click on one face of my band, hit the delete key on my keyboard, and it will delete the band and rebuilds the part into a sharp edge. And also here, this side, I will rebuild to a sharp edge by deleting the band. So, and now what we learned from our first part, it should be possible by using the conversion tool to modify the sharp edges by using the junction functionality. In this case, it's a bend. And by clicking, like what we did earlier, on the red edges, I can easily modify the sharp edges into round bends again. And after that, I can create a sheet metal part out of it. So bring on upper and lower tool category for getting the right shortening factors, that the unfolding is then correct. Afterwards, I'm now able to create a cutting geometry, which I can use for cutting, bending, stuff like this. So just imagine like what we did. Also the reliefs and stuff like this can be modified with this, whatever, laser symmetric corner or whatever you need there. Also, it depends on what kind of technology you use, punching or laser or combined machining. So this can lead to a different shape of corner relief. So just one more things on this part, and I will maybe load it again, because sometimes my first move, what I showed in the first step, repairing this model, is not possible. I can also, when I maybe rebuild the edges into sharp edges and then convert again into sheet metal, I will not be able to create a 2D file out of it, because still there are some missing faces or splines or some curves, whatever, in this bend that leads to that it is not possible to create an unfolding. Another possibility which I use quite often to repair corrupt files is goes like this. I will start with the select tool, and with a double click on, in this case, I use the inside face, I can collect only or all the faces from the inside of my model. Afterwards, I hit the Control and C keys on my keyboard and the Control V key on my keyboard, just for copy and paste the surface which I collected. And as you can see in the structure tree, I have an additional surface which is only like a foil, and this is the collected inside face of my solid. So why am I doing that? Because now I can delete the solid file. I know already it is corrupt, so it's not helpful to maybe repair, and to save time, I will delete it. And now I have some more tools in here in this edit section. I can use the pull tool, and with this active pull tool, I will click on the surface in the structure tree, which leads to that it is highlighted again. And as you can see, I have now this arrow which shows in direction. And in our case, during the collecting the inside face, I know now that I need to thicken up this face into the opposite direction. So in my case, I must thicken up this face in the minus direction. Of course, I need to make sure that I know the thickness, how thick the part should be. In my case, it's 0.05 inch. Hitting Enter key on my button on my keyboard, and then I'm coming back to a solid with existing bands, because the roundings were also in this surface. And now I can use again the convert tool and convert my new created solid model into a valid 3D file, which could be after validation. So bringing on again upper and lower tool category could be then easily unfolded, and the 2D file I can then use for additional things, cutting, bending, and so on. So this is the second thing I showed, really a nice feature to repair models which have missing faces, corrupt bends, and it's really, really fast and easy to create out of this a valid solid file that is then usable for every additional step you want to make. So coming back to our presentation, just for a short sum up of our second problem part with this corrupted bends, was not made for sheet metal due to the missing faces and the corrupted bends. It was not able to unfold it. My solution, step number one, was I reconstructed the solid, deleted the bends into sharp edges, converted these again with this convert button into sheet metal part, which leads to that I was able to unfold it. And the second step, and just once more, this is maybe the most efficient way in Boost to solve these kind of problems. I collected the inside face or the outside face, it depends on where you want to start, deleted the solid model, thickened up in the right direction and with regards to the thickness, again into a solid file, and then I could also use convert tool, created the sheet metal part out of it, and I was able to unfold the 3D model into a 2D file, and then from there on I can go on with any additional steps technology-wise. So, second problem solved. One more to go. Thank you. I have a part with some missing faces, which leads to that it is also not possible to create anything out of it. So just jump back into TruTops Boost and open again text on design. I have this part here, and at least you can see in the structure tree something strange happened. I have 4 solids because the files, the solids are not connected due to whatever conversion from native file to common file. So, and also there some tricks, tips to repair such a model file with maybe the learnings we have from the first 2 parts. So first of all, I will always try to use the convert function. By clicking on convert, I can then click on one of our solids, and I think you can see the bend changed its color to this magenta thing, which means this is an existing bend, which I'm able to validate afterwards in this case. Also, maybe I try to convert the middle section, which is the biggest section here in our part. Maybe also there, I just try to convert the file, the solid into sheet metal part, and also there I'm able to convert it by using the functionality into sheet metal. But again, maybe I don't have the possibility, maybe this file, to convert it. Then once again, I can use select tool, click on the bending, hitting the delete key on my keyboard, and by using convert functionality again and the correct junction, in this case it's a bend, I can click on this red line and convert the sharp edge into a bend. Or let's go back really quick. Also here, it can be possible, or if this conversion does not happen, remember, double click one face, copy, paste, will get this face, which then can be thickened up in the right direction with the thickness, and it will lead to that you will have a valid solid in this case. So just let me delete the face. I think that's clear. And I will just rebuild this bend by deleting the radius and convert this single part again with the right feature bend. But still, I have this 4 volume models here in my structure tree, because we still have or facing problems because the parts are not connected. So also here I will use junction functionality, and it's really simple, I would say. Use the select tool, and with the control key, I can select more than only one face. And once these 2 faces are selected, I can use again the junction feature with active bend, and this leads to that it will create a bend between these 2 faces. So once more, active select tool, hidden control key, I'm able to select 2 faces, or 3 or 4 or 5, depends on what you want to do. And then afterwards, I can easily say I want to create bend also between these 2 faces. And yeah, as you may notice, when I'm connecting different solids with bends, it minimizes the number of solids in my structure tree. So one is still missing. Again, select control key, select the 2 faces, and with the junction tool, I can then combine these 2 solids. And after that, I'm able to create sheet metal part out of it, which leads to that I can now create an unfolding, a 2D file, which I can use then for additional stuff. So also this really nice functionality to repair models which have completely missing bends or basis. Also, this is possible by using the maybe, let's say, 3 steps we learned so far. So going back to our slide here, second problem was the part with the missing faces. Was not made for sheet metal due to the missing bands. And combining on this part everything we saw so far, I can convert maybe solids by using the convert tool. Sometimes it works. If this is not working, I can rebuild bands by deleting the radius, coming back to a sharp edge, which is then possible to convert again into a bend or an overlap, a slit, whatever. Third method is collecting inside or outside face, thicken up into the right thickness, and after that I can convert it to a bending part or sheet metal part, and in this case creating from these 4 solids only one. It's also possible to select faces, and with this junction feature I can then create some bands or different seam shapes. That's also possible, but at least I will end up in a solid which is valid and made for sheet metal, which is then possible to unfold and move on with any additional steps I want to do with this. So this was a short overview how to deal with corrupt files with some, I think, very helpful tips and tricks. I want to thank you for listening.